Hey, welcome to Zona Mechanica. There is an MCQ on thin pressure vessels. Actually, there are two questions based on same data, linked answer type of questions. Figure at the margin indicates the weightage of the question, that is 2 marks. It means each of the question carries 2 marks. The statement for the two linked answer type of question is a cylindrical container of radius r is equal to 1 meter, wall thickness 1 millimeter, is filled with water up to a depth of 2 meters and suspended along its upper rim. The density of water is 1000 kg per meter cube and acceleration due to gravity is 10 meter per second square. The self weight of the cylinder can be used at all points along the height of the cylindrical container. Well, as you can see, this is the cylinder and it is hanging above the upper rim, and the radius r is given is 1 meter and the height of the water is 2 meters. Okay, and the wall thickness is 1 mm. Since the density of the material of the cylinder is not given, so we cannot calculate the self weight of the cylinder, and since the wall thickness is very low, that is 1 mm, so we will ignore the self weight. Okay, so the question number 1 is the axial and circumferential stresses, that is sigma A and sigma C, experienced by the cylinder wall at mid depth. Okay, at mid depth, that is at 1 meter from top or bottom. So let us first realize what is circumferential stress and what is axial stress. See, the fluid in the container will exert pressures in all directions, right? So the wall of the cylinder will experience two types of stresses. So if we cut like this, then it will look somewhat like this. This is called sigma C, hoop stress or circumferential stress. Okay, sigma C. And if we cut like this, then it will look like this. So this is a cross section, wall thickness. Okay, so it will experience a stress like this, right? So this stress is in the axial direction. In the axial direction, this is the axis, so this is called axial stress. Okay, so we have expressions for axial stress and circumferential stress. So the expression for axial stress is P into R by 4 into H. H is the wall thickness. This is H. Okay, wall thickness is H. P is the pressure exerted on the wall. Okay, for axial stress, the weight of the entire liquid will act, okay, through this wall. So P will be H into rho into G. So H is the height of the liquid 2 and rho is 1000 already given. G is 10, it is given. Okay, into R is 1. Okay, 1 meter. So into 4 into H is 1 mm, that is 0.001. This is in meters. Okay, so it will give 5 into 10 to the power 6 in Pascal, Newton per meter square, that is Pascal, is 5 MPa, right? And the formula for circumferential stress is P into R by H. That is P means circumferential stress at the mid depth. that is at 1 meter. So H rho G, H is 1 into rho is 1000 into G is 10 into R, okay, divided by 0.001, okay. So this will give 10 into 10 to the power 6 pascals, that is 10 megapascals. The sigma A is 5 MPa and sigma C is 10 MPa. Clearly, it's matching with option B, 5 and 10, okay, respectively. So option B is the correct answer.